Now let's illustrate the same Holt-Winter model with transformation. So we'll know how to do it. The only difference is the first point you have to change from auto sales to the ln of auto sales. Once you do that, then you go through the same procedure, but at the end you have to convert the forecast got for the ln auto back to auto. So that's the only difference. So let's go ahead and first set up the transformation. So that will be ln of auto sales. Copy that. Okay. Then let's put some trial values there, and m is 4. Now let's set up the initial values. Okay. T is average. Now this time we have to use the ln data set minus the average of the first years, average of the second year minus average of the first year. Okay, so now you divide that by m. So that will give you the trend starting point, initial value. So here, initial value for L, you take the average of these, then you have to add m minus 1 over 2 times the trend. Okay, then we need to set up the initial values for S's, so that will be the average of the first season from the two periods. Okay, let's enclose that with parentheses, and then we divide by the average of two entire seasons. Okay, that two entire seasons must be absolute referenced. So now we can copy that. So that gives us the initial values. Now our first forecast for the ln value would be the sum of the previous L and T, and multiply by the seasonal index. Now we can set up the ln value and the ln forecast value. So that's our error. Now we can set up the three smoothing values. So that will be the same like here. So the first one, L, will be the sum of the previous L and T plus alpha, absolute reference that, times E, okay, divided by the smoothed error. The T would be the previous T plus, now alpha, absolute reference that, times beta, absolute reference that, okay, times E divided by the seasonal index, the same season, the previous cycle. The seasonal index is the previous seasonal index of the same cycle plus gamma, absolute reference that, times E sub t divided by the sum of L and T from the previous season. And we need one more parenthesis. So that sets up the smooth values. Now the forecast is you take the ln forecast and you enclose them with exp. exp is the antidote for ln, and that takes us back to the original values. Now we can copy these and we have the model set up. Now let's set up the error messages and run solver. Again, remember the fitting sample starts from 1968 through 1999, and the holdout sample starts from 2000. So first MSE. So now the auto sales. Don't do this with the LN and LN. We converted from auto sales to LN and did the forecasting, and then we have converted back from LN to the original unit. So you have to look at the original unit with the original unit. Auto sales with the auto sale forecast. So that's MSE, and the same range holds for MAE, MAPE, and RMSE. Copy that. You need to set that up separately. Now the MASE range, the baseline random walk forecast is 1967 through 1998. And same range for Thiel's U, and there it is. And the same set of measures for holdout sample going from 2000 to 2006. So 2000 to the end, 2000 to the end. Again auto sales, to auto sales, actual value forecast. The Y column and the AF column. And same range for these three. And here same range as these for the first two, and the third one will go from 1999 through 2005. So that will be 181 is 1990, 150, sorry. Y150 is 1999 through 2005. Same there. Now we need to run solver. This is the previous solver, so reset, and we'll select RMSE to minimize, and by changing cells or the new alpha, beta, gamma cells, and that should be less than or equal to 1, and check these, and then run solver, and we get the best alpha, beta, gamma values for the transformation model with Holt, winter model, smoothing. And so now we have the three models, and let's go ahead and summarize. For the fitting sample, or estimate sample, fitting sample, and holdout sample, these 5 meshes. So we have 3 different methods that we use: additive method, multiplicative method, and multiplicative method with the transformation. So we have MSE from the very first one for the fitting, and then the second model, which is that one, again fitting, and this is the LN model with fitting. So now we can copy this across to get the rest of them. All right. So let's make MAPE percentage. Okay. Do the same thing now, this time for the holdout sample. Holdout sample, MSE for the first one, MSC for the second one, and MSC for the third one. So now we can copy this across. And let's make that into a percentage. And now we have a comparison. You see the estimate, and here they all are better than naive model. And the best one seems to be the additive method. Well, actually, when you look at the holdout sample, so this is for the estimate. You need to look at the holdout sample, and you see the multiplicative method with the LN transformation seems to be the best. Okay. And another strange thing happening here is the holdout sample, all the methods are doing better with the holdout sample than with the estimate sample or the fitting sample. That's a little strange.